Solve the following logarithmic equation. So before we get to this equation, I want to take a minute to look at a few methods of solving logarithmic equations. One method is to convert your logarithmic equation into an exponential equation. So you start off with something in this format here, y equals log base b of x. The base of the log is the base of the exponent. The log always equals the exponent, which is y, and what's inside the log is what the exponential expression equals. The other method that's used often is sometimes called the one-to-one property of logarithms, and sometimes it's called the property of equality. In this method, you have to have log with the same base on both sides of the equation. Log base b on one side, log base b on the other side. And because logarithms are one-to-one functions, what's inside those logarithms have to equal each other. So you have the expression inside the log on the left being u, the expression inside the log on the right being v, and those have to equal each other. It allows you to get rid of the logs in the equation. For this example, I can see I have log of 8x plus 10 equals 1 plus log of x minus 4. I do have log, and no base is specified, so that means this is base 10 on both the left and the right side, but because of this plus 1 here, I'm not going to be able to use that one-to-one property or property of equality. So instead, I'd like to use the method of converting to an exponential. But in order to make this work, I need to have a single log on one side of the equation. So I'm going to do a little bit of rearranging to start off. I'm going to subtract log of x minus 4 on both sides of the equation. That leaves a 1 on the right. On the left, I have log of 8x plus 1 minus log of x minus 1. Now I'm going to be able to condense these two logs into a single log because they have the same base of 10, or sometimes it's called the common log. Now because it has subtraction, we're going to condense this using what's called the quotient rule. So that gives me log of 8x plus 1 over x minus 1 equals 1. So just to take a moment to clarify that quotient rule, this expression inside the log goes in the numerator because this log is positive, and the expression inside this log went in the denominator because that log was negative. And now that I've got a single log on one side of the equation, I can convert this to an exponential. I'm going to use a base of 10 because no base was specified. The exponent is the 1, and this equals the expression inside the log, which is 8x plus 1 over x minus 1. So 10 to the first power is 10. I can multiply both sides by the denominator to clear fractions. That gives me 10x minus 10 when I use the distributive property. And on the right-hand side, those denominators canceled out, leaving me with 8x plus 1. I want to get all the x's onto the same side, so I subtract 8x. That's 2x minus 10 equals 1. Now that I've got x, all the x's on one side, I'll get x by itself. I'm going to add 10 to both sides. That's 2x equals 11. Divide both sides by 2, and I have x equals 11 over 2. Now, with every log equation, you should check to make sure that you don't have any solutions that wouldn't work in the original equation. So I'm going to check x equals 11 over 2. In the original, log of 8 times 11 over 2 plus 1 equals 1 plus log of 11 over 2 minus 4. Now what we're checking for is to make sure that we're taking the log of a positive. Log of a negative is undefined and log of 0 is undefined. So here I've got a positive times a positive plus a positive, so this expression will be positive and that's okay. But over here we have log of 11 over 2 minus 4. 11 over 2, let's see, 2 goes into 11 5 times with 1 left over, so that's 5.5. So 5.5 minus 4 is also a positive, and so we're going to be able to keep that solution of 11 over 2. So the solution to the equation log of 8x plus 1 equals 1 plus log of x minus 4 is 11 over 2. Thank you for checking out my videos. Have a great day.